Good afternoon, everyone from Chicago. Just a quick sound check, checking in. I wonder if we can have you raise your hand on the control panel so I know that you can hear us. So there's a little control panel there that you can just kind of raise your hand. Very cool. And if you want to have fun, just type into the text or into the chat or text it into the question box that you can hear me. And that way we'll know we've got sound for everybody too. So you'll see me looking off to the right, my right, your left. That's where my controls are. I've got your names here, got who the presenter is over here, the question box over there, and the chat box there too. So we're all set there. Okay, big thanks everyone. Appreciate you hopping in, raising your hand. Nice to see the program loading up with people. So good afternoon from Chicago. My name is Bill McHugh, the Executive Director of the National Fireproofing Contractors Association. Today's program on fire resistance codes, standards, and testing. Rich Walke is going to drive the bus on this one, a consultant to the NFCA. Rich and I have been working together on stuff since the early 90s, and he's been working with us as a consultant to the NFCA since he retired from UL after 43 years of service over there. He had the opportunity to work in fire testing and then also in regulatory services for a lot of years, where he was educating code officials about the important things to know about standards, codes, and testing from the UL perspective. So really appreciate Rich hopping on and doing this program, and we'll look forward to a great program. But before we get started, let's talk a little bit about the NFCA. The National Fireproofing Contractors Association. For those of you that are members, a big thank you for your dues, which pays for what we're doing today. Without your dues, I can't be here running these webinars. We can't have Rich online doing the webinars with us. Without you, we can't do anything. So if you're a member, big thank you. If you're not a member, I'd like to reach into the webinar, grab your credit card out of your pocket, and have you join the NFCA. info@nfca.org. info@nfca-online.org is our email address. Just email us with the contractor or other application, and off we'll go. Very quickly, I put up the board of directors because a thank you to them. Many of them chair committees at the NFCA, but either way, they volunteer their time to set the direction for the NFCA and come together for board meetings, whether they're teleconferences or face-to-face. We do at least one face-to-face board meeting in Chicago every year where they fly in, and we do a full day of industry strategy, NFCA strategy, and much, much more. The NFCA has also done a lot over its existence. It's been around for just about 20 years, maybe a little bit more, but not much. The founding executive director, fine gentleman, Hugh Dudley, who I actually met when I was 24. Both of us at the time were working for a manufacturer of fireproofing materials. He was a really good base setter, I'll say, and helped us set the base with the NFCA contractor accreditation program, actually. We've then taken that and grown it, added text, added educational material to it, and much, much more. And then decided, you know, the NFCA needs to get out and get busy doing things it should be doing in the fire resistance industry through the building codes, through the building standards development process, and also through the fire codes. So when you look at this slide and all the stuff that we've been up to, it's really what we've been trying to do, is find ways to make sure that fire resistance and structural fireproofing included is an important part of the building safety mix. When we go to the code development hearings, you see the picture on the upper right there. When we go to those hearings, one of the things we hear all the time is sprinklers are 99.99% reliable when they operate, hence the catch, and therefore the building's safe. In other words, you don't need anything else. Our opinion is sprinklers are excellent and should be part of the total protection package, but so are the alarm systems, the detection systems that detect fire, smoke, and alert occupants to do something, whether it's clear out the smoke or get out of the building, whatever it is, that notification system is hugely important. Education of the occupants is also important. City of Chicago, after its 2004 fires, there were two of them, LaSalle Bank and the Cook County fire, The fire department went to every high-rise building, super high-rise building in the greater Loop area and educated the building occupants about what to do in a fire emergency, how to stage the stairwells, not to pack them too much, and what to do, where to go for your havens of safety. Fire resistance is a really important piece of that package. That's why we're at ASTM building inspection standards and making them better for fireproofing, both IFRM, SFRM, and we've even got one going for boards and wraps. Boards and wraps aren't mentioned specifically in the special inspection section of Chapter 17 of the Building Code, but they are if we go into the scoping section, because there's an equivalent to it in the 1705-1415 area. You'll find fireproofing, SFRM and IFRM fireproofing in special inspection. Go back in the scope section, it'll actually tell you that we should be doing that for boards and wraps. So we're building a standard for that. We're at the NFPA Fire Protection Features Committee. We're at the National Building Code and Fire Code of Canada. We've got a couple of proposals in there. We work with our friends at the AISC and the AISI, our friend Jonathan Humble, Charlie Carter, and many others, to really make sure that fireproofing and fire resistance is not eliminated. At the Building Code Development hearings this year, last year I should say, 2022, Rich and I were at Louisville, Kentucky. One of our colleagues stood up after they changed the word fire resistance to fire safety in 104.11, the equivalent section. One of our colleagues stood up and said, hey, guess what? Fire resistance has been eliminated. Well, guess what? It wasn't eliminated. The word was changed from fire safety to fire resistance. You still have to, when doing equivalencies, look up to the equivalent section in Chapter 7, 703, if you will, for structural fire resistance, and make sure whatever is being proposed is actually equivalent to that is demanded through the intent of the code. So it's important that your NFCA is there to make sure the industry is represented well, has a voice, and is made sure that we're just as important as everything else in the building and fire codes. So yeah, Rich Welke and I go hang out at these International Code Council, the NFPA Fire Protection Features Committee. We're online with the National Building Code of Canada and other places. Off my shoulder, whoops, other shoulder, you'll see a picture of the NFCA's. You'll see the actual book of the NFCA's Handbook of Accepted Fireproofing Knowledge. That's another thing that we did to try to augment what Hugh Dudley did, was build a print document that's a textbook that people can learn from. That's what that is. NFCA members get a great big discount on it. Designers, code officials, those that are involved in code development as far as the AHJ crowd and the specifiers, we'll get you a PDF of that for free. Just hit us at info@nfca-online.org. We've got hundreds of these out already to the greater community on it as well. Got some great education programs. We've got a conference coming up in Charlotte, North Carolina. We're going to have a blast at the University of North Carolina Charlotte campus. There's a Marriott right there that we'll be hanging out at. Got a great program on project management, estimating, obviously codes and standards, inspection, and much, much more. A lot of great speakers at this program. As a matter of fact, our friend Bob Davidson are going to be coming from South Carolina to talk to us about batteries and electric storage systems in buildings and how that works. We've been working with UL to build this UL Qualified Fireproofing Contractor Program over and above our NFCA accredited contractor program. In addition to, I should say, we relaunched it right in the middle of COVID, April of 2020. And we've got some contractors that we know are in the process of getting themselves accredited through the UL program. Over 50% of our membership is already an NFCA accredited contractor. I know the deadline says January 31, but you know, maybe we'll extend it a week or so. But if you're a contractor and you're on the webinar here, know that the Award of Excellence call for entries is up January 31st. Get your applications in. We'd love to feature you at our conference and then feature you at a webinar at a future date as well. A lot of good stuff coming at that conference. And I mentioned NFCA's education and exams for the designated responsible individuals takes place at this conference. Yeah, we offer a couple of them virtually, but really the best way is face-to-face so that the attendees, the students can ask questions of the instructors. Rich Walke and I, along with representatives from GCP, Isolatech, Carboline, Hilti, and others, present as part of that education program. So a lot there. The NFCA's done a lot. We've got a bigger package than we ever had as far as membership benefits, but probably the biggest one. You know, most people and companies ask, well, what's in it for me as a contractor company for joining the NFCA? Certainly all the regular things that you get with an association, conference, e-newsletter, webinars, all that kind of stuff. Yeah, we do that stuff. But the bigger thing that we do is advocate to make sure that structural steel fire resistance and structural fire resistance, because sometimes it's on concrete as well, isn't forgotten in the building codes and standards arenas. That's a big deal. And really, it's part of your dues that make that work. And without you, we can't do that defense, if you will, and offense to make sure that we've got the right fire resistance in buildings. We also have some technical standards, NFCA 100 and 400. Those standards you can use as a third-party reference to tell the general contractor, hey, it's not me as a fireproofing contractor saying this, it's the industry that says this. That's what that's all about. And then certainly you get listed at nfca-online.org. The recording for this program we'll put up for 2023 at the website. This one we leave open and free all year long. And the reason why is because the more people we get educated about ULC, S101, ASTM, E119, UL263, the better off we think our industry will be. So if you want to be a member, email Kristen at nfca-online.org or info@nfca-online.org. If you want a free handbook of fireproofing knowledge, if you're an authority having jurisdiction or a specifier, email us again and we'll make sure to get you that as well. So at this point, let me start moving the slides over to Rich so we can make him the presenter, and then we'll be off and running with today's program on fire resistance codes, standards, and testing. So Rich, I'll give you the control, and slides are yours. Drive the bus.
Okay, great. Thank you, Bill, and thanks for the introduction earlier. And a warm welcome to everyone in the audience from Peoria, Arizona, where it's a sunny but cool afternoon. But cool is a relative term. It's about 57 or so degrees here, and in most parts of the country, of course, it's much cooler. So it's nice to be here. But anyway, so our focus today is fire resistance rated construction. We're going to talk a little bit about the code requirements. We're going to talk about the testing. We're going to talk about some listing information, and hopefully give you a better feel for fire resistance rated construction, what it's all about, where it's used, how it's used, and so on and so forth. So the concept behind fire resistance, of course, is that all the other fire protection features within the building have not worked. We now have a fully evolved fire post flashover condition, and now we're trying to contain the fire to that room or floor of origin through the use of construction techniques and building materials which are designed to resist the long-term impact of fire. So if we can contain the fire to the room or floor of origin, it will give time for the folks to get out of the building and also minimize the damage to the building so that hopefully it will be able to be repaired after the fire event. And so let's start by talking about the code requirements relating to fire resistance. And for the most part, I'm going to focus on the International Building Code, but of course there are other codes here in the US. We also have the NFPA Life Safety Code 101, and we have the NFPA Building Code, NFPA 5000. Has never received much adoption, but it is out there, it is published. But in Canada, we have the National Building Code of Canada. All of these codes have requirements relating to fire resistance. Certainly in the US, the NFPA and ICC codes really have similar technical requirements. Certainly the structure of the codes differ between the two organizations, but the basic requirements are essentially the same. The processes are also a little different in terms of how those codes are developed. So because of that, sometimes we end up with slightly different variations of the requirements, but usually by the next code cycle, the one or the other of the codes catches up to the other one, and we end up with consistency once again. So the requirements are very similar between the NFPA and ICC codes. In Canada, they are a little bit different because of the, a slightly different approach in terms of the fire separations in Canada, some of which may be rated, some of which may not be rated, but essentially the requirements are very similar. And I'll also say that for the most part, for our discussion here today, we don't need to be too concerned about which edition of the code we're talking about. In the arena of fire resistance rated construction, the requirements have not changed significantly over the last few editions of the code. And as such, we'll reference the 2021, and with one exception, which I'll bring up when we get to that point, the codes are very similar to the previous editions. So fire resistance is covered in a number of chapters of the International Building Code. Chapters 3, 4, 5, 6, 7, and 10 all address fire resistance rated construction and where rated construction is required. And from there, the individual chapters have focuses where we define the various items that are needed to understand fire resistance and understand where the ratings are required. So starting with chapters 3 and 4 then, those chapters define building occupancies. In other words, how is a building being used? So for each occupancy, there's a kind of a level of hazard associated with that occupancy. For example, if you have a business occupancy, there's a certain inherent level of hazard associated with that versus, for example, a manufacturing environment. The hazards may be different. So chapters 3 and 4 address those occupancies and uses, and once that's established, those facts will be used to determine what fire resistance rating is required. When we get into chapter 5, we define the general building heights and areas. In terms of the building height, that would be based on the occupancy and the type of construction of the building. Now, we haven't got to the type of construction yet. I'll get there in just a minute, but basically the type of construction relates to what materials can be used to construct a building of that type. And ultimately, some types of construction, a type 1, is inherently very fire resistant or fire safe because it's required to be constructed for the most part using non-combustible materials. On the other end of the spectrum, we have a type 5 building, which can be constructed of any materials permitted by the codes. What does that really mean? For the most part, when you talk about a type 5 building, we're talking about combustible construction, lumber construction. So those are your extremes, and then we have 2, 3, 4 in between, which bridge the gap between those two extremes. And again, each of those types of construction has some relative safety associated with it, which is then used to ultimately determine the height and area of the building. As far as the area of the building, it's determined based on 4 factors. It's determined based on the type of construction, the occupancy of the building, the available frontage around the building for fire protection access, or fire service access, I should say. And then also the last component of that is whether the building is sprinkled or not. So by knowing those 4 factors, one can then get to what is the allowable building height and the allowable building area. And in general terms, the more inherently safe the type of construction is, the larger the building can be, and also then inherently the less hazard associated with the occupancy, again, the larger the building may be. And then we get into section 508, which covers mixed use considerations. Now, realistically, most buildings nowadays of any reasonable size include occupancies there include different occupancies. For example, you might have a building where the first floor is mercantile occupancy, small shops, for example, at the street level. And then at the upper levels, you might have residential applications. Well, there's a different relative hazard associated with those occupancies. So the code then requires that those occupancies be, different occupancies be addressed in one of three manners. And the one manner of significance to us here would be, one method of addressing the differences is to separate the occupancies using fire resistance rated construction. And the code has a table which defines what the required rating would be depending on what the two occupancies that are being separated are. So that's certainly one approach, and there are a couple other approaches which I won't get into here today. So I mentioned types of construction before, and types of construction ultimately dictates the allowable height and area of the building. Something that is a type 1 construction, non-combustible, typically is permitted a larger building area and larger building height than a type 5 combustible construction. So table 601 is a very important table of the code. That table then establishes the hourly rating required for the various building elements based on the type of construction. And so very important table. There's another table, table 705.5, which in the earlier editions of code was table 602, which establishes the hourly rating required for exterior walls based on the fire separation distance, the type of construction, and the occupancy. And that table has a graduated scale. The more fire separation distance you have to the lot line, the lower the rating would be, and at a certain distance, that rating requirement falls by the wayside completely. So again, in significant table within the code. And then we get to chapter 7. Chapter 7 is entitled Fire and Smoke Protection Features. At one point in time, this section was, was titled Fire Resistance Rated Construction, but Bill McHugh put forward a code change for, I believe it was the 2012 International Building Code, that changed it to Fire and Smoke Protection Features. And that was done in recognition that Chapter 7 covers more than just fire resistance rated construction. It also covers the migration of smoke within that building. So the more current title more accurately reflects the intended uses of that chapter of the code. So I call chapter 7 the nuts and bolts chapter of fire resistance. It details how one achieves fire resistance rated construction. And it starts with some general information up front, and this is one area where the code did change with the 2021 code. Section 703.2 defines 3 methods of complying with the code requirements relative to fire resistance rated construction. And the sentence version of the code reads, fire resistance ratings shall be determined in accordance with section 703.2.1 or 703.2.2 without the use of automatic sprinklers or any other fire suppression system being incorporated, or in accordance with section 703.2. And this is one change with the 21 code that, to be honest, I am not a fan of this change. It was put forward by a representative from the sprinkler industry, but if you read the words, what it does is opens the door to the use of a fire suppression system in order to establish a fire resistance rating. Now, personally, as a fire protection engineer, I disagree with that concept. We always talk about that fire protection triad consisting of fire resistance, fire suppression, and fire detection mechanisms. When we use a sprinkler system to establish a fire resistance rating, we're really combining 2 legs of that stool, if for whatever the 3-legged stool of fire protection triad. So if you were to lose the fire suppression side of the protection, you would really lose 2 legs of that 3-legged stool, and the full stool would topple over. So for that reason, I'm not a fan of this section of the code, because it kind of opens up the door for that concept. And anyway, so I think the passive fire resistant industry needs to keep an eye on this to make sure this does not get out of hand. There's currently one listed product of Tyco water sprinkler that does address a combination of fire suppression and fire resistance. But any case, so let's look at these three methods of showing compliance with the fire resistant requirements in more detail. You know, the first one is tested assemblies. It says fire resistance ratings shall be determined in accordance with ASTM E119 or UL263. And I think that's probably obvious that those two standards are the basis for everything that's fire resistance related. Those standards are the methods of determining your basic rating of your building elements, floors, roofs, walls, beams, and columns. It also served as the foundation for the various methods which are now in place for determining how to protect breaches in rated construction. For example, fire stops, joints, doors, and dampers. All of those standards on those breaches have their origin with ASTM E119 or UL263. So anyway, that is one method. Run a fire test to that method, present the test report to the code official, let the code official review it, that 100-page long report, and make a determination of whether that construction described in that report meets provision of the code, which presumably what it would be, it would. But any case, is that a practical method of determining fire resistance? No, it's really not. You know, it's beyond reasonable to expect the architect to track down those reports run by the various manufacturers, read them, see if they meet their needs, submit it to the code official, get it approved that way. So fortunately, the code has some additional methods to show compliance, which I'll get to in just a minute. Those additional methods are the practical methods. But under the tested assemblies provision, we have a couple points which I'll bring up. First of all, it says non-symmetrical walls shall be tested from both faces, and that makes sense. You know, what's a classic example of a non-symmetrical wall? You know, a little outside of this industry, but a classic example of a non-symmetrical wall would be a gypsum board shaft wall. Those walls are constructed differently on the two sides, and as such, based on the provisions of the code, and for that matter, the standard, they're required to be tested twice, you know, once from each side of the assembly. The code goes on to say assemblies shall be considered unrestrained unless a registered design professional provides evidence satisfactory to the HJ that the construction qualifies for restrained classification per ASTM E119 or UL263. And in my opinion, this is probably the most widely misunderstood concept of fire resistance. We could talk for an hour on what that really means, but we don't have the time to do that today. There was a webinar in February of 2000 where this was addressed in detail. So if you have questions on that, feel free to go back into the members only section of the website and pull up that webinar to give more details on it. So moving on, this is the second of those three methods for determining fire resistance or showing compliance with the requirements for fire resistance. It's called analytical methods. It says methods for determining fire resistance shall be based on the fire exposure and acceptance criteria of ASTM E119 or UL263. So the first sentence there sets the stage that we're still talking about E119 and UL263 as the basic concept behind fire resistance. And then it goes on to establish 5 practical methods of showing compliance with the codes. And that first one says designs documented from approved sources. You know, that section probably doesn't have a lot of relevancy to your industry here, but to other industries it may. Classic example of that approved source would be the Gypsum Association Fire Resistance Design Manual, GA 600. It's a quasi UL directory, gives the details of the constructions, not to the level of detail UL uses, but it gives the general details of the assembly and what its rating would be, used widely for that particular industry. And then the concrete industry has a similar document, wood industry has a similar document, so on and so forth. The second general method is prescriptive requirements from section 721. And by 721, I mean section 721 of the International Building Code. So right within the building code, we have, again, kind of quasi-UL designs, describes the construction and what those ratings would be. So that's another method of determining fire resistance. The third one covered here is calculations in accordance with section 722. And 722 of the IBC is a method of calculating what your fire resistance rating would be of a particular construction. It assigns a particular time value to the various components of the construction, and then you simply add up the components that you're using. What is the resulting fire resistance rating? Does it meet my code requirements or not? If it does, you're good to go. If it doesn't, then you need to add more components. For example, in the realm of gypsum board construction, you might need to add an additional layer of gypsum board on each side in order to meet that code requirement. So anyway, it's calculated fire resistance right in the IBC. The fourth method is what I refer to as engineering judgments. It says engineering analysis based on ASTM E119 or UL263. And again, in my view, I call that engineering judgments, but we could also look at that from the perspective of the evaluation services. ICC Evaluation Services publishes a number of acceptance criteria, typically in cases where the code is not clear on what the requirements would be. That certainly is not the case in fire resistance. The code is very clear in terms of what the requirements would be. So typically we don't use evaluation reports that frequently in the fire resistance area. Other areas, they're very, very common. And then the last option is fire resistance designs certified by an approved agency. Now that would be your designs from the UL fire resistance directory, nowadays published online in the form of the Product IQ online directory. It would also include directories from Intertech, from Factory Mutual, and other testing laboratories. And then the third of those methods for determining fire resistance would be the approved alternate methods. Required fire resistance is permitted to be established based on the alternate protection methods in accordance with section 104.811. So, realistically, 104.811 has existed for decades, and basically it allows the building code official to consider alternate methods of construction that meet the intended level of safety required by the prescriptive requirements of the code. So, theoretically, this would allow the code official then to consider this, Tyco window sprinkler as an alternate to a fire resistance rating. There's an ICC evaluation report that establishes the fact that wetted glazing is equivalent to a 2-hour fire barrier. So this section of the code allows the code official to consider the possibility of accepting that concept for a building. So this is the area that we need to be a little careful with the fire resistance industry to make sure that concept does not get out of hand. But in any case, so to summarize then fire resistance, chapters 3, 4, 5, 6, and 10 really establish where the required fire resistance, or what the required fire resistance ratings would be. And yes, there are some other chapters that do have requirements for fire resistance, but these are the primary chapters that address what fire resistance ratings are required. Chapter 7 establishes how those ratings are determined. I call that the nuts and bolts of fire resistance. And ultimately, the rating is expressed in some hourly time period. Those ratings typically range from 1/2 hour up to a maximum of 4 hours. And the concept is the fire resistance is intended to contain the fire to the room or floor of origin and to maintain the structural integrity of the building. Okay, so now we're going to move on to the next general topic is how do we establish those fire resistance ratings? Now this is something near and dear to my heart since I spent about 19 years at UL actually involved in fire resistance testing, both of the basic barriers and also of the methods of protecting the breaches or holes, openings, voids, and so on in rated construction, breaches in other words. So we're going to talk about the methods of establishing rating on the basic barriers, your roof, the floors, the walls. I'm sorry, we won't cover walls since that's typically not something that's done through fireproofing type products, but we'll cover floors, roofs, beams, and columns. So in terms of standards, there's really 4 standards in North America that address fire resistance. Here in the US, we use ASTM E119 and UL263 as the basis for determining fire resistance. Those 2 methods are spelled out in all of the US-based codes. At one point in time, there was a 3rd method, NFCA 251. That standard was withdrawn, about 7 or so years ago. And the concept of that withdrawal of that standards is the fact that standards development is a very time-consuming and as a result a costly process. It takes a lot of effort to maintain the standard even once it's written. So the 3 standards writing organizations, ASTM, NFPA, and UL, got together and said, we're going to try to minimize the situations where we have identical standards covering the same test procedure. And so in the spirit of that agreement, NFPA 251 was withdrawn, and over time you'll see more and more of those standards being withdrawn, and ultimately probably won't happen in my career, but I would suspect somewhere along the line either ASTM E119 or UL263 would be withdrawn also, but again, that's not going to happen in the immediate future. So up in Canada, they use a similar standard, ULC S101. And from the perspective of the technical requirements, ULC S101 and the US-based standards are for all practical purposes the same. They can be considered interchangeable. All the test methods describe the same test equipment, the same test procedures, same conditions of acceptance. So, typically a fire test run here in the US in accordance with the US-based standards can be considered as meeting the requirements of ULC S101 also. So in terms of testing, the standards divide the building elements into the basic elements: columns, beams, floor ceilings and roof ceilings, and wall assemblies. All fire resistance tests are conducted with a furnace exposure represented by this time temperature curve. So this is the assumed fire exposure that you would have in a typical commercial building fire. And as such, that's what's replicated in the furnace. So this curve would start at an ambient temperature. At 5 minutes, the temperature within the furnace would reach 1,000 degrees Fahrenheit. At 1 hour, the temperature within the furnace is 1,700 degrees Fahrenheit, and at 4 hours, it's 2,000 degrees Fahrenheit. So this curve is used throughout the entire realm of fire resistance rated construction, at least as intended for typical building construction. Same curve is used for the various breaches, and also the same curve is used up in Canada. There is another time temperature curve which is applied to the petrochemical industry, which we won't get involved with here today. It's kind of outside the scope of our discussion. So what I'm going to do is I'm going to go through a series of slides showing the fire test procedures for the basic elements: columns, beams, and floor ceiling or roof ceiling assemblies. So we'll talk about how each of those are tested individually. So let's start with the columns. That's the simplest one, pretty basic. Standard would require that the minimum size of the test sample is 9 foot in height. And in most cases, columns are tested unloaded. Now, the test standard does define 2 test procedures. One of them, the acceptance criteria, is temperature-based, and the other, it's load-based. The reality of it is that there is no testing laboratory here in North America that has capabilities of loading columns during the fire test. So all tests typically used here in North America have been tested using the temperature-based acceptance criteria. We'll talk more about that when we get to the acceptance criteria. So here's an example of some columns that are being prepared for testing. So in this case, the testing laboratory would typically purchase the structural steel. They'd pour a concrete cap top and bottom of the assembly. They would install thermocouples on or in the structural steel. The tip of that thermocouple embedded 1/16 inch into the steel. And then the lab would turn over the assembly to the manufacturer who would in turn then install the fireproofing products to the steel. Now, in this particular case, it's an intumescent fire-resistive material being applied. And the gentleman doing the application is from the manufacturer. And then while that's being done, the UL technicians will be recording the process on how that's done and the thicknesses of the protection that's applied. Once that application is done, the material is allowed to cure, and then it's moved over to what UL refers to as their column furnace. It's basically a big box. The sample column is slid into the box. There's a sand base applied at the bottom of the furnace. There's a couple different reasons for that, and I'll show you a photo in just a minute that shows the impact of that sand base on the performance of the material. But essentially, that sand is intended to allow the lab to get the instrumentation thermocouples out of the furnace into the data acquisition system. And then just before the start of the test, the fourth wall of this furnace is closed up, and then the temperature within that furnace is heated following that standard time temperature curve I showed you earlier. And the visual observations are made in terms of how the material performs, but the real acceptance criteria is temperature based. When the average of the temperatures reach 1,000 degrees Fahrenheit, that would be the temperature endpoint, or when any individual point reaches 1,200 degrees Fahrenheit, that would be the other endpoint. So when either of those events occurs, that is the fire resistance rating for that particular size, shape of steel protected with that particular material for that particular, or at that particular thickness. Now, if one was to conduct the test load bearing, the criteria would be this column needs to support the load if tested load bearing. Now, again, I said before, there are no labs that are capable of loading these columns here in North America anyway, but people always ask, is that a shortcoming of the standard? Are we missing something by not loading these columns? And the reality of the answer is no, we're not. UL has had the opportunity numerous times to witness tests of columns in other parts of the world where it's common to load the columns during the fire test. And ultimately, the conclusions that have been reached is the fact that the temperature-driven criteria is more conservative than the load-driven criteria. So in other words, if you were to test the same material, use the temperature criteria versus a load supporting the load criteria, the temperature criteria would reach the endpoint earlier, giving a lesser rating. So it demonstrates that what we're doing here in North America using temperature is in fact more conservative than what's being done elsewhere in the world. So here's a photo of the base of a column that's been protected with an intumescent fire-resistant material. So the lower portion of this column was embedded in that sand base that we saw in the photo of looking into the furnace. So you can see down here we'd have the material that's essentially at its original thickness, and then as that material projected up through the sand to the interior of the furnace, we see it did see some heat. It began to expand. When you get up to this portion, that portion is fully exposed to the fire, and you can see the resulting expansion that occurs on that particular type of material. Here's a photo of a test that perhaps I'll say didn't go so well. And this photo points out two things. One, it points out the fact that we're always going to need fire testing. You know, we can do fire modeling. UL's been using fire modeling for decades to supplement fire test performance, but a fire model can't necessarily predict if the material is going to stay on the column or not. So this is a classic example where the material did not adhere, laminated, and that's something that would never be picked up in fire modeling. So fire modeling needs to be approached cautiously, needs to be done in conjunction with actual test data. The test data basically establishes that the material will stay in place, along with provides a data point by which to compare the results of the fire modeling, make sure we have correlation. So bottom line is a good example of why we don't use fire modeling exclusively for determining fire resistance ratings. The other thing that this points out is the fact that we need large size samples, building element size samples, in order to establish these ratings. If you were to run the same material, same thickness on a short column, maybe 2 foot in height, I would be highly doubtful that we would have ever seen this delamination. So the test standard requires minimum 9 foot samples in order to be able to have a representative section or area to, test the ability of the material to stay in place. So now let's move over and talk about beams. Beams are tested in a similar manner, only they're horizontal elements, so they're tested horizontally. Beams also typically support either a floor ceiling or roof ceiling, so there's a representative section of a floor ceiling or roof ceiling applied to the top of that beam. So the standard says that the minimum size of the beam shall be a minimum length of 12 foot, and beams are always loaded to their maximum design capacity during these fire tests. So again, I've got a series of slides that show the construction process for test assembly for beams. So at UL, they use the concept of a 4-beam assembly. I still use the phrase "we" to describe UL, but I've been retired for 3 years from UL, and I'm still catch myself saying that every once in a while. But in any case, UL uses the concept of testing 4 beams within one horizontal assembly. So in other words, we're developing 4 data points through one fire test. So we've got 4 beams that are spanning, in this case, the short dimensional furnace. At UL, the sample size is 14 foot in the short dimension, 17 foot in the long dimension. So it meets that minimum 12 foot as required by the standard. And from there, the lab will install, in this case, representative sections of a concrete steel deck floor ceiling assembly. So you can see there's 4 distinct assemblies within this one test frame, separated by about a 1-inch gap between the adjacent assemblies to allow differential deflection during their fire test. So the deck is put in place. These pipes are projecting up. Those are simply saddles or supports for the hydraulic rams that will be used to load the assembly during the fire test. And then the concrete is poured over each of those 4 sections. Now we've got 2 of them poured at this point. The 3rd one is underway. Now all 4 sections have been poured and leveled smooth. And now what do? Well, we let the concrete cure. How long do we let concrete cure? Everyone says 28 days rather. Well, not in terms of fire testing. From the perspective of fire testing, concrete is cured for roughly 4 to 6 months, and that's done at an elevated temperature and low humidity conditions, about 115 degrees Fahrenheit and about 20% relative humidity. In other words, Phoenix in the summertime. So even just with those advantageous curing temperatures and humidity conditions, it still takes 4 to 6 months to cure that concrete. And then once that's done, the manufacturer's rep would come in and apply the fire protection material. And the beauty of a test like this, they have 4 beams to work with. So they can do any number of different things with those 4 beams. They can use different materials, different thicknesses of material. They might even use a beam in one of these sections and a joist in another. So that points out the versatility of this 4-beam concept. So anyway, assemblies are protected with the materials to the thickness the manufacturer is predicting is required to achieve a certain rating. And then will be subjected to the test. This is a photo of the UL horizontal floor furnace rather. Andy is standing in the furnace, so you get a relative idea of the size, 14 foot by 17 foot by about 6 foot in height. These long rods projecting up are thermocouples, which are used to measure the temperature in the furnace. These shorter pipes are the gas pipes used to supply the fuel for the fire. So the assembly is placed on top of the furnace. It's then loaded to its maximum design capacity through the use of hydraulic rams located at the midpoint and quarter points of the length of those beams. And then the fire test is initiated. During that test, what we're doing is we're visually observing it again. Visual observations really don't have a place in terms of the conditions of acceptance, but they do give the test sponsor an idea of how their material is performing. The criteria for establishing the rating really relates to 2 things. It relates to whether the assembly supports the load and also temperature-based criteria. When the average of all the thermocouples on that beam reaches 1100 degrees Fahrenheit, or when any individual thermocouple reaches 1300 degrees Fahrenheit, that would be considered the temperature endpoint for that particular construction. Now, so ultimately a little more complicated than what I'm making it sound like. This all interrelates to the concept of restrained versus unrestrained, but again, I don't think we have time to get too much more involved in that concept at this point. So let's now turn our attention to floor ceiling, roof ceiling assemblies. Again, we have minimum sample sizes, 180 square foot area for the floor ceiling or roof ceiling, and no dimension less than 12 foot. And once again, horizontal assemblies are always loaded to their maximum design capacity. And there is an exception to the code. We'll talk about that in a bit, where you can test something at some lesser load, as long as the resulting design and report clearly specifies what that lesser load might be. But for all practical purposes, most all assemblies are designed or are tested at their maximum design capacity. So again, I've got a series of slides showing the construction. This is a very, very old slide looking down at the assembly from an overhead mezzanine. So you can see we have the test frame again. We have one structural element running the short dimension of the furnace. And then the next slide will be a closer view of a more modern test, where we've got the beam again running this short dimension of the furnace. Now the steel deck is being installed. We've got it installed on one span of the assembly. Now the steel deck has been installed on the second span. Shear connectors are welded through the deck to the top flange of the beam assembly to provide that composite action between the concrete and the steel. And wire mesh is typically utilized to prevent that shrinkage cracking. And then concrete is poured on the top of the deck to create that finished floor ceiling assembly. Once again, that assembly is allowed to cure for that 4 to 6 month time period at the elevated temperature and low humidity conditions. And then the manufacturer comes in, applies the protection material to the underside. Now, this particular assembly shows the steel deck and the structural element is protected with a spray applied fire resistant material. And it is installed to the thickness that the manufacturer is predicting is required for the rating period that they're attempting to achieve. Once again, it's tested using UL's full-scale horizontal floor furnace, and assembly is placed on top of the furnace, and then it's loaded to its design capacity. Typically, the structural elements are loaded through hydraulic rams, again at the midpoints, quarter points of the span, and the general floor area is loaded with water tanks. And the beauty about loading with water tanks is we can simply vary the depth of water in those tanks to apply whatever live load is necessary to get to the design capacity of that particular assembly. So once that loading process is done, the thermocouples are connected to the data acquisition system, and then the furnace fire is ignited, and we then make visual observations of the events occurring within the furnace, along with looking at how that assembly is performing relative to the 4 conditions of acceptance. So the conditions of acceptance, once again, relates to whether that assembly supports the load. Also, do we have flaming on the unexposed surface? In other words, flame passage through the assembly. Typically, that wouldn't occur, of course, on the type of assembly I've just shown you, a concrete steel assembly, but it's not uncommon to have that occur, for example, in a roof ceiling assembly where we use combustible insulation on the top side of that roof assembly. The other criteria that's applied is the temperature on the unexposed side of the assembly cannot exceed an average temperature rise of 250 degrees Fahrenheit for all the thermocouples, or an individual point temperature rise of 325 degrees Fahrenheit. And then we also apply the same support temperatures that we talked about for that beam assembly. So I'm going to show you a very quick video of how these fire tests are conducted, and hopefully it gives you a better appreciation of how that assembly is tested. So here again, we're looking down at the assembly from that overhead mezzanine. The assembly has already been placed on the furnace, and now the lab staff at UL is connecting the various pieces of data acquisition. instrumentation. Now the furnace fire has been ignited. We're starting the test. What we're doing is we're looking through, in that last view, some water-cooled cameras that UL has located around the perimeter of the furnace, so we can, see what's going on inside the furnace. And this is through one of the viewports into the furnace. Again, there's some cameras that are viewing into the furnace, so we can see what's going on in the furnace. Here you'll start to see some deflection on that steel deck. This happens to be for a 4-beam test, as I showed you earlier. So we do get some relative deflection. And both the UL folks and the client representatives are typically monitoring what's going on. There you can see a pretty significant deflection of that assembly during the fire test. This is very typical of the type of deflection that you would get on a horizontal assembly. So let me show you one slide here of a assembly that was tested at some point in the past. I was not involved in the fire test, so I can't give you a firsthand account for what happened, but what do we see that looks unusual in light of the video we just saw? Well, there's two things. First of all, we don't see the deflection that we saw in the video. So that tells me that this test was terminated early. The other thing, of course, that we see is massive delamination of the sprayed fire resistant material from the steel deck. So putting 2 and 2 together, what happened on this assembly is the material delaminated very early. The test sponsor decided to stop the test early, save the natural gas, and that's why we see very little deflection, but yet massive delamination. So once again, could we determine this through fire modeling? No. We cannot. The only way we know whether the material will stay in place is through the actual fire testing process. Okay, so that completes what I was going to talk about as far as a testing process. We've got a few minutes left, so let's go through some common questions, misconceptions, and misunderstandings relating to fire resistance. So I've just developed a few questions that relate to fire resistance, and basically these questions come from the questions that the association gets from both its members and from outside parties, and also questions that I used to get back when I was working with UL. There was a period of time at UL I was involved in UL's what they referred to as the Architectural Services Hotline, where anyone can call from the outside world, ask questions of UL about the listings, how those listings relate to the codes, and technical questions relative to the content of these designs, for example. So these sort of questions I'm posing here are sort of the questions we used to get on that line. So the first question is, what's the difference between ASTM E119 and UL263 versus ULC S101? And the realities of it is ASTM E119 and UL263 are US-based standards, which are referenced in the US-based codes and some international codes, which are based on US codes. For example, United Arab Emirates Fire and Life Safety Code is very heavily based on US codes, and as such, reference these two standards also. ULC S101 is a Canadian standard that's published by Underwriters Laboratories of Canada, now referred to as UL Solutions of Canada, and it's referenced in the Canadian-based codes. Now, as I said before, for the technical content, the three standards really are very, very similar. They differ in format and layout, but the technical requirements are essentially identical and can be considered, or the results can be considered equivalent. So the next question would be, what's the difference between a UL listing, a CUL listing, and a ULC listing? Very common question. If I had a nickel for every time I was asked that question, I'd be a wealthy man. But in any case, a UL listing is issued by UL Solutions, formerly known as simply UL, based on US standards and is intended to address US-based code requirements. A UL listed product will bear one of the marks shown at the bottom of the page. And UL is in a transition period where they are updating the format of their listing marks, and the terminology used on those listings. The lower left is the traditional UL classified mark. And basically a UL classified mark indicates that the material has been evaluated to one particular test method and one particular hazard, in other words, and the ratings published are based on that one specific hazard. The format of that is changing. This center format is what UL is calling their enhanced mark, and then the right-hand side is what they're referring to as the enhanced and smart mark. The beauty of the smart mark is you can just use your mobile phone to take a picture of that QR code, and it will take you to the listing of those products. But any case, for the most part, most manufacturers are still using the older UL classified form of the label, but more as time goes on, more and more you'll see the enhanced and smart mark. A CUL listing then is a listing issued by UL Solutions based on the Canadian standards and is intended to address Canadian base code requirements. So that CUL really refers to Canadian UL mark. So a CUL listed product will bear the mark which are based on one of these two symbols. So again, the CUL mark is issued by UL here in the US based on Canadian code requirements. The third mark, the ULC listing, is something issued by UL Solutions of Canada based on the Canadian standard and is intended to address Canadian-based code requirements. And again, this is the logo for that mark would be the ULC in conjunction with the word listing. Now, one might say, don't we have some redundancy here? The ULC mark and the CUL mark are all, for all practical purposes, one and the same. I shouldn't say they're one and the same, but they are redundant. One is simply issued by UL here in the US, one is issued by ULC up in Canada. So yes, they are redundant. In a perfect world, UL will be at some point in time merging the two marks, coming up with one Canadian mark that really reflects listings from either UL here in the US or ULC up in Canada. But that hasn't happened yet, but I suspect it will be. It's been talked about for a lot of years, so it's coming and it's needed. And then we do have some products which will bear a mark, a UL mark for US-based applications and a CUL mark for Canadian-based applications. So the way you'll be able to identify those products is it'll have the letter C on the left-hand side and US on the right-hand side. So that mark would imply that this product has been evaluated to both the US and the Canadian requirements and is listed by UL for use in the US and for use in Canada. If we go over to the enhanced mark, we'll see that US-Canada over here, again depicting this mark, or for the product that's bearing this mark can be used either in Canada or in the US. So let's look at our third misunderstanding. And the question would be, is it necessary to leave space around a building element which is protected with an intumescent fire-resistant material? And the answer is yes. These intumescent materials need space for free expansion in order to develop proper char formation. Again, I'll say if I had a nickel for every time I've been asked this question, I'd be wealthy. You know, I get inquiries oftentimes from architects and contractors who want to protect a structural element with intumescent material and then wrap it with gypsum board in direct contact with that intumescent material. No, that is not appropriate. Those products do need space for free expansion, and that is stated in the UL guide information for fire resistance. And that guide states that unless otherwise detailed in the individual designs, mastic and intumescent coatings are tested without any covering adjacent to the tested member that might interfere with the expansion. The effect of the fire resistance rating of steel members caused by any coverings that would interfere with the expansion of a mastic or intumescent coating has not been investigated. And then it says contact the manufacturer for those required clearances around the structural members. So the manufacturers will be able to give you the information in terms of how much free space their product needs. Basically, that'll be based on what's the expansion rate, or not rate, but expansion factor. How many times its original thickness does this material expand to? So they'll be able to help you out and give you that sort of information. Then the fourth question would be, the building configuration prevents the application of protection on one side of a beam or column. What can be done to properly protect this element? Again, very, very common question. And you know, the basic premise is an assembly that's tested to the standards we've been talking about are protected on all exposed side. And by exposed side, for example, for a column, I'm really meaning the entire perimeter. For a beam assembly, typically that beam is protected on the top flange through whatever floor or roof is above it. So in the case of the exposed sides of a beam, that would be everything except the top flange. So those assemblies are tested in that manner. If, for example, you have a column that's close to a wall assembly and can't get to the back side or one side of that column, how do I address that? Well, ultimately, those are typically dealt with through an engineering judgment. And, you know, manufacturers have developed a number of creative solutions for that issue and have issued engineering judgments. UL has issued a number of engineering judgments relating to the issues like that. And typically, though, you need to address it through an engineering judgment. And, you know, contact your manufacturer when that situation develops. And then the next question would be, does small scale testing have a place within fire resistance rated construction? And the general answer is absolutely it does not. You know, ASTM E119 and UL263 requires minimum sample sizes to allow for a realistic deflection and realistic surface area during the fire test. You know, that photo of the column where we had massive delamination, we wouldn't have seen that had we been using a small sample. And likewise, for a horizontal assembly, you don't get the deflection, which ultimately results in the fact that the material on the bottom flange of that assembly, typically the bottom flange of the beam, might possibly delaminate. So the standard does have those minimum sample sizes for a very specific reason. The other issue is small scale assemblies typically cannot be loaded as required by the standard. So small scale testing needs to be done very judiciously to supplement full-scale testing. It is not a standalone testing by any means. And where I say supplement, for example, if you ran a test assembly with a beam supporting a concrete floor assembly, similar to what we saw earlier in the video, and you achieved a certain rating, you can easily adjust the rating of the beam through the UL beam equation in the UL guide information, but you can't do something like that for the steel deck. So UL uses, and other labs, uses small scale testing to supplement, to alter not alter the ratings, but to determine what thicknesses would be necessary for other rating periods beyond what was just tested under that full scale assembly. But UL doesn't stop there when they do that testing. What they'll do is they will reproduce the test that was done full scale on a small scale basis, determine if the small scale adequately or accurately predicts the same fire resistance rating, and then if not, use an adjustment factor for any other supplemental small scale testing that's done. So it's a correction factor, so to speak, to correct for the difference between small scale and full scale testing. So ultimately, the standards and as a result, the codes require full-scale testing. And by full-scale testing, what I really mean is tests conducted on samples that meet the minimum size requirement of the two standards. Now, when I say small-scale testing, I'm not sure I know what that means, other than it's a size that doesn't meet the requirements of the standard for minimum sample size. That small scale column could be 2 foot long, could be 4 foot, 6 foot, etc. But all we know is small scale does not meet that minimum size requirement. So, if you're asked to consider data on assemblies that it looks suspicious, if you have questions about whether this was run full scale or small scale, ask the question. Ask the manufacturer to provide data, test reports that demonstrate these assemblies were conducted using full-scale testing as required by the standard. And Bill McHugh mentioned very early in the program about the fact that we had submitted several code proposals that referenced the need for full-scale testing. The code committee came back with, it's already required. The standards require, and as such, the code requirements. We don't need to put it in the code any further. And that was the right answer. So we now have the documentation to support that position. So the last question I'll pose is, are horizontal assemblies required to be loaded during the fire test? And yes, certainly they are. ASTM E119 and UL263 requires the assemblies to be loaded to their maximum design capacity, and, as calculated based on nationally recognized structural design criteria. There is a provision in the standard that does allow a lesser load, but very few assemblies are tested at a reduced load. If a manufacturer tests an assembly at a reduced load, it radically restricts the ability of the architects and contractors to use that assembly in the field. And if it was tested at that reduced load, the design will very clearly spell that out. And by designed, I mean from UL or the other testing laboratories. But again, if there's some question whether the assembly was loaded or whether it was conducted small scale, ask the question, ask for that test report. So one last concept I'll address. I know we're running out of time, but
Okay.
we have one more question. Are engineering judgments a get out of jail free card to avoid the use of tested designs? Question is absolutely not. Engineering judgments are not a substitute for tested assemblies and should only be used after exhausting the search for that tested assemblies. So it is a way of evaluating those unique site-specific conditions where there are no tested listed designs. So the justification for that the use of an engineering judgment goes back to section 703.2.2 of the IBC, that engineering analysis based on E119 or UL263. Now the question is, who writes these engineering judgments? Well, obviously that party needs to be knowledgeable on fire resistive testing and the performance of materials that are used to establish fire resistance ratings. Who that exactly would be is kind of up in the air. I see 4 parties that could write the judgment. Perhaps a PE, perhaps a fire protection engineer, perhaps the manufacturer of the fire protection material, perhaps the testing laboratory, or for that matter, folks like myself who have immense experience and background on fire resistance. But the best advice that I have found for weeding out who is a knowledgeable party to conduct or do these engineering judgment is have the code official ask for a resume or CV of that individual issuing the EJ to get a better understanding of their qualifications. If their background suggests they've been involved in the topic for a lot of years, testing, design of products, so on and so forth, well, then they're probably qualified. If their background shows they've designed sprinkler systems their entire career, even if they are an FPE, well, maybe they're not the right person to be writing that judgment. And certainly the code official has the right to reject an engineering judgment. Just because it's written doesn't mean the code official needs to accept it. So I always have been telling code officials for a lot of years, ask for that resume or CV, understand the person's credentials, and are they qualified to do that judgment. And the other last point about an engineering judgment is they are issued for a specific job site. So the engineering judgment should always reference the building in question. Okay, so now we're ready to take some questions.
Thanks, Rich. Really appreciate that. Well done on lots of different fronts. 2 different questions came up. First one is, does building category, in other words, that table 1604.5 that has category 1, 2, 3, 4, does that have any effect on fireproofing requirements in buildings?
In general terms, no, it doesn't. Those are risk categories. Those are buildings that are intended to remain functional under emergency conditions, natural disasters, and those sort of things. So it doesn't directly tie into fire resistance ratings. Yes, there are some special provisions that are sometimes applied to those. One that quickly comes to mind is special inspections are sometimes applied to those types of buildings where they're not applied to other types of buildings.
Fair enough. Next question came up. Can you dig a bit deeper into restrained and unrestrained, between the two? This question comes up at every conference we have, and that's okay. Go ahead, Richard.
It is okay, yes. So how long do we have to do this now? Well, I'll give you the short version of that answer.
Yeah.
And let me also remind you, there was a webinar on this specific topic, and I believe it was January of 20 that addresses it. So we can get you copies of that presentation. They're available on the website if you want to go back and get more information. But bottom line is the concept of restrained or unrestrained relates to, is the building restrained rather from thermal expansion under fire conditions. In other words, as that horizontal assembly is subjected to fire, it's going to tend to expand. Is there anything that it can expand up against that will restrict that thermal expansion? If there is, ultimately you can get away with using less fire resistant material on that structural element for a given rating period. So what you need to do is analyze what is the construction of that building, and is there something that's going to resist that thermal expansion? And if so, you can take advantage of the fact that that is restrained and use lesser fireproofing on those types of assemblies. And there's two ways of going about that. You know, the UL guide information for fire resistance does publish the relative stiffness of the UL test frame. UL considers those frames to be very, very rigid and meet the requirements for restraint. So if your building is at least as restrained as the UL test frame, the building can be considered restrained, something the structural engineer is going to have to calculate. The other more practical answer is there's a table within the two standards, UL263 and ASTM E119, along with the UL guide information, that basically describes the type of construction and it concludes whether it's restrained or not. So that's the more practical solution of making that determination. But what it all boils down to is the building restrained from thermal expansion under fire conditions?
Fair enough. Looking for more questions. Two things. First one is the person that asked the question about restraint. That helped a lot. So, well done, Rich. Thank you. Second thing is, thanks. Very informative program from one of the people that hit the road on us. Looking at the question box, I'm not seeing any questions coming in, so I'll call it out. Going once, questions going twice. I'll wait a minute for the 3 times. But I think, Rich, your added addition of those questions was a really great idea to do. That's different than last year's. And really, those are some of the top 5 questions. And if you think about it, you know, every year at the NFCA conference, we do a top 10 question thing. We're going to put out for even more to our membership to email us at info@nfca-online.org. Email us questions, your top 10 from a contractor perspective or a consultant inspection agency perspective, and we'll answer those during part of that program and that conference as well. The other big thing I really appreciate you saying was that the code official doesn't have to accept every alternate solution that's thrown at them, and that they really ought to look at the fire resistance with a really keen eye. They meaning the code officials, fire marshals. And if they're unsure, bring in a consulting organization to talk about, you know, tell me about what's acceptable, what's not. And be careful too, because, you know, the ultimate purchaser is, if there's a fire, it's the occupant sitting in the building. That's the big thing that we have to be careful of, is that judgments are just that, they're judgments. If we got fire testing, then we should be relying on that for making determinations before we start thinking about engineering judgments of any kind. On intumescence, Rich, are we supposed to be doing engineering judgments on intumescent materials?
Well, there's no real reason you cannot, but the person doing those judgments do need to look at those types of products perhaps a little more critically than you would with a spray applied fire resistant material. You need to make sure you have room for free expansion and that sort of thing. But in theory, it can be done, yes.
Okay, fair enough. Looking up, don't see anything in the chat box, don't see anything in the question box. So I guess what we'll do is call number 3. Call for question number 3, all done. Looking up again, I'm not seeing anything on the control panel. Just a big thanks to Rich Walke, consultant to the NFCA, for taking some time out of his schedule to present this program Most people say to us, I've watched something like this before, but every time I watch it, I pick up one or two more little points. And that's huge. I mean, everything in life is cumulative, just like a mathematics program. You learn addition, subtraction, multiplication, algebra, trigonometry, calculus, on and on and on and on. It all builds on each other. So, even though we do these once a year, sometimes more, and talk about some of this stuff more often, we don't know where our members and attendees are in that cumulative experience. They could be at exposure number 1, they could be at exposure number 3. We know that it takes at least 5 hits of the head for me to remember to pick up the milk and the orange juice on the way home. So let alone remember what fire resistance and how important it is in buildings as well. So a big thanks, Rich. Really appreciate all you do. A big thanks to the members for your dues, because without your dues, Rich and I can't do what we do here for the NFCA, for our education and exam programs, whether it's live or doing the virtual program. We did 3 or 4 of those last year, the virtuals, or attending the ICC, International Code Council, code development hearings, NFPA and ASTM meetings to make sure that your industry has what it needs when it comes to actual field experiences. So big thanks, Rich. Big thanks to the audience, and we'll look forward to seeing everybody next month.
Okay. Yeah. Thank you, everyone. Thanks for joining us. Have a great afternoon.
Thanks again, everyone.